Okay, this is Unit 2, or Lesson 2 of Unit 6. What we're talking about today are rectangles. This is kind of a short one, but it's got a lot of important information in it. So let's take a look to see what we got. Okay, the first thing about this, we're going to start with some definitions and things. So the first thing we got is a rectangle is a parallelogram in which all four angles are right angles. Okay, notice it does not say that one pair of sides is longer than another pair of sides. This is because that the only definition that we have for rectangles simply says that all four angles have to be right angles. So this means a square that we'll talk about in the next lesson is also a rectangle. Okay, all the properties of parallelograms apply as well as this additional one. So what they're telling you here is go back to the previous lesson and all the things that we learned there about the opposite sides being the same length, the opposite angles being the same length, consecutive angles adding up to 180 and all that kind of good stuff is applicable to rectangles as well. Okay, but here's the one that they add to it. This is the other thing that you can use to identify rectangles with. If you have a parallelogram and the diagonals are exactly the same length, then that means that it is a rectangle. Okay? So what they want us to do here, given all this information, is they want us to find the measures of angles 2 through angle 12 in this rectangle. Okay? Notice that they gave us a little bit of information. They told us this one angle up here is 75 degrees. So we're going to work from there. Okay, so example 1. They want us to find the measure. We're going to find the measure of angle 5, which is this one down here, which is equal to 75 degrees, because since these lines are parallel, this is a transversal, these are alternate interior angles. So all those are definitions that you need to be aware of so that you can function with these. Okay. The next one we're going to find is we're going to find the measure of angle 2. So the measure of angle 2, since we know this big angle up here has to be a right angle, these two angles have to add up to 90. So the measure of angle 2 plus the 75 is equal to 90. Subtract the 75 from both sides, the measure of angle 2 is 15 degrees. Okay, the next one we're going to find is angle 6. Once again, these are alternate interior angles, so angle 6, well, they're going to go at it the same way they did angle 2, since you know angle 5 is this, but you could use the alternate interior angles and say that angle 6 is 15 as well. Okay, but you can do it this way just as easily. Okay, the next one they're going to do is the measure of angle 3 is equal to 15 degrees. Okay, the way they got this is by using the fact that these are triangles. Okay, so the triangles have 180 degrees in each one, so this is where you're going with it. So this means the measure of angle 7 has to be 15 degrees also, because it's alternate interior angles again. Okay. So the measure of angle 12, which is this one right here, plus 2 times the measure of angle 15, or 2 times 15, which is these two angles right here, has to equal 180. So the measure of angle 12 is equal to 180 minus 30, which is 150 degrees. So this is 150 degrees. Angle 11 will have to be 150 degrees by vertical angles. Okay? That also means that we can find the measure of angle 8, which, once again, we know this one's 15, so if we put these together, this one has to be 75. Okay, and that's what they did right here. Okay, angle 4 has to be 75 because, once again, they're alternate interior angles. Measure of angle 10, this one right here, is equal to these 3 angles added up, so I know that both of these are 75. So all 3 of those angles have to add up to 180 because it is a triangle. So this gives us 30 degrees here. Angle 9 has to be 30 degrees because it's a vertical angle to angle 10. Okay, so you have to use all these angle pairs over and over and over again for stuff that we're going to be doing, especially with parallelograms. Okay, example 2. In rectangle ABCD, the length of DE, which is this part right here of this diagonal, is x minus 3. The length of AE is 4x minus 6. What is the value of x? Well, one of the things they told us is one of the new properties we have is that the diagonals are congruent to each other. And one of the previous properties from parallelograms said that they bisect each other. So this piece right here is half of this one's half of this one. So these two actually have to be congruent to each other. So that gives us AE is equal, the length of AE is equal to the length of DE, which gives us 4x minus 6 equals x minus 3. Solve this for x by subtracting x from both sides and adding the 6 to both sides. That gives us 4x minus 6 equals 6 minus 3. So this gives us 3x equals 3 when we simplify. Divide this out, gives us x is equal to 3 divided by 3, or 1. Okay, so x is 1. If we wanted to know the length of this, all we have to do is take the 1, plug it back in. 1 minus 3 is what? Something that's not good. You get a negative amount. Okay, so while this is the true solution for x here, that would not be a valid length of this. Okay, so we always have to check it to make sure. Okay, just like the other end is going to give us the same thing, but the whole deal here is simply that. Okay, we solve for x, and that's what they ask us to do. Okay, I believe that's the end of this one. We will see you in class. If you got any questions about it, feel free to ask, and we'll clear it up before we start. Thank you very much. Goodbye.